Welcome to this video on the topic of inequalities. In this video, I'm going to show you 5 examples that will highlight the process involved in rearranging inequalities. So looking at example 1 here, we have x plus 5 is greater than 7. The way in which we typically rearrange inequalities is basically the same as if we're working with an equation. So what we can do is we can move the constants to the right and the variables to the left. So following that process, we're going to first move the constant of 5 over to the right by taking 5 from both sides. I'm going to put in my inequality operator. Go x is greater than 7, take 5, and then we find that x is therefore equal greater than 2. So the rule in which we follow for rearranging inequalities is just treat them like they're equations. Mostly. So this isn't always going to be the case, but for the most part we can treat them like they're just regular equations. Now example 2, we have y minus 2 is less than 4, take y. So notice here we've got both constants and variables on either side of the inequality symbol. Now to do this, what our objective is we want to move all of our constants to the right hand side, and then we want to move all of our variables to the left hand side to make the variable y the subject of this inequality. So first things first, we need to add 2 to both sides. So this will give us y, then 4 take y plus 2. Rearranging, we'll get 4 plus 2 take y, and that will equal 6 take y. Next step is we want all of our variables on the left hand side, so we're going to add y to the right hand side here, and therefore add y to the left hand side, like so. That's going to look like just 6 on the right, and then y plus y on the left, which will give us 2y is less than 6, and dividing both sides by 2, we're going to get y is less than 3. So basically treating it like it's an equation. Going down, example 3, we've got something slightly different. We've got 4 is greater than or equal to z. So once again, let's go ahead and treat this like it's an equation by flipping the expressions about the symbol. So this is going to look like z and 4. And for now, I'm just going to keep the inequality operator the same. But this is going to lead to a bit of a problem. The problem is that we simply can't just rotate or flip the expressions about, because have a look at the initial statement here. 4 is greater than or equal to z. So think about what that would look like. It means that z is going to take on any number that's less than 4. Now if we look down at this statement here, z is greater than or equal to 4. It's contradictory to what the first line says, so there's a bit of an error here. Rather, what we need to do when we reverse the order of expressions is we also need to reverse the direction of the inequality symbol. So fixing this up, rather than z is greater than or equal to 4, what we'll find is that z is less than or equal to 4. So if we were to plot this on or look at this on a number line, and we had a 4 over here and we had a z over here, what we're effectively looking at is z is less than or equal to 4. So it's all of these numbers to the left of 4 here. So 3, 2, 1, and so on. So every number to the left, not what we can see up in z, or here z is greater than or equal to 4. So this line here is wrong. Alright, example 4. 3 plus 3a all over 2 is greater than or equal to a plus 2. So what we're dealing with here is a mathematical statement of the complexity that we're pretty capable of doing with regular equations. Now the way in which we rearrange this is we'll simply follow the exact same rules we follow when we're rearranging equations, keeping in mind situations like this. So first step is we're going to collapse this fraction by multiplying both sides by 2. Nice and easy. Then we're going to move all of our constant terms to the right hand side. So we'll take 3 from both sides. This is going to give us 3a, 2a plus 4, take 3. Then evaluating, that will be plus 1. Then we want to move our variable terms to the left, so we'll take 2a from both sides. It's going to look like 3a take 2a is equal to 1. Then sorting out the coefficients, we're going to get a single a is greater than 1. So what you can see from this example here is we're basically treating these as if they're equations, and the only time that we change the rules is if we saw a situation like this, which of course we didn't over here. Alright, going down to example 5, we're dealing with a inequality statement with an inequality, and it's 2 fractions. Now, thinking about how we can deal with this, what we'll do is we'll get rid of the fractions by having a common denominator and then multiplying both sides of the inequality by the denominator. So to make a common denominator, we'll go 3 times 4, so we'll go 3 over 3 over here, and then we'll go 4 over 4 over here. That's going to look like 3 plus b all over 12, and then we're going to get 2 plus b over 12. Now I'm going to multiply both sides by 12 because I really don't like working with fractions. They're just so then we're going to get 2 plus b, then 3 plus b, and then opening up the brackets, we're going to get 8 plus 4b, then 9 plus 3b. Moving our constants to the right hand side, we're going to take 8 from both sides, and then this will collapse down to 1 plus 3b, 4b, and then moving all the variable terms to the left, we're going to get minus 3b minus 3b. That will look like 4b minus 3b, then 1 on the right, and then simply b is less than 1. So nice and simple.